Seventh grade math, test 26. Problem number 1 says George uses 2 1/3 cups of flour for every 5/6 cup of sugar for a recipe. What would be the number of cups of flour he should use for every 1 cup of sugar? So what we want to do, if they say sugar at the end right there, we want to know how many per 1. So we just take and we put the sugar amount second, and we divide those two. That will tell us how much per 1 of whatever the second one, or give us a unit rate where the second one is equal to 1. So again, they say sugar last, and you put the sugar last. So we divide these two. First, I convert this into a fraction, an improper fraction, by multiplying 3 times 2 and then adding 1. Then how do I divide by a fraction? I multiply by the reciprocal. How do I multiply fractions? I do my factor trees and cross out my 1's, and my answer will be reduced. If I look at my answers and I don't see an improper fraction that matches mine, then I can convert by dividing in and out. Remember, the remainder goes on top, divisor goes on the bottom. Number 2 says this table shows a proportional relationship. And then it says enter the number of grams of granola in a bag for every 1 gram of chocolate. Again, they say chocolate second, so we put chocolate second. I pick any point on there I want. I can pick the first one or the second one. It doesn't matter. I'm going to get the same answer for all of those. So I go 10 divided by 4. Again, factor trees cross out my 1's, convert it to a mixed number, and you guys get the answer of 2.5 grams. Alright, number 3. Number 3, we have an expression here, and we're going to say which expressions are equivalent to this. So the first thing I want to do, that I can do, I recommend you do, is that you do your rule for subtraction. So wherever we have a subtraction problem, we're going to draw 2 sticks. We're going to do add the opposite. So I did it here, and I'm going to do it here also. Now I can use teams. Once I do that, I can use teams. So I'm going to go ahead and add up my like terms, and all x's are like terms with other x's. I have 3 negative x's, that goes on the negative team, 2 positive x's on the positive team, and 8 more positives. I add up all my positives and my negatives in opposite teams at the end. I subtract, and then I ask myself who has more. That gives me my sign of positive 7x. Do the same thing for the constants. I have negative 9 and positive 7, and so I put those on teams. Opposite teams means subtract. Who has more negatives this time? So that expression is equal to 7x plus negative 2. So the first expression, expression 1, is 7x minus 2. That's the same as 7x plus 2. If I did the rule for subtraction, I get the same expression. Expression 2 says exactly 7x plus negative 2. And expression 3, if I were to take this and I take 8x and take away one of those x's, I'd get 7x minus 2. Same thing. You can do the rule for subtraction in teams. And expression 4, if I took that and I took 10 x's and I took away 3 of those x's, it adds 7x plus negative 2 also. So all of those are the same this time. So for number 4, we have this long expression here, and they want us to see which of those students have the same expression. So we're going to simplify this. Okay. So again, we can do rule for subtraction, and to simplify means to distribute and combine like terms. So I'm going to go ahead and distribute the 8 there since it's outside of the parentheses. So I multiply 8 times negative 7x to get negative 56x, and 8 times 8.2, which is 65.6. Now I'm going to combine like terms. I add my x's with my x's and my constants with my constants. Remember, when they're on the same team, we add them together. And I say who has more? Well, they're all negative, so of course negative has more. Now remember, negative times negative is positive, but negative plus negative is negative. These two I do teams again, I get 62.5. And I'm going to start checking these students. Well, Rick wrote this expression. We got to simplify Rick's expression to see if it is equivalent or not. So I go ahead and do that. I do the rule for subtraction here. I combine my like terms. There are more negatives than positives, and I see that's the same expression as the one given. So Rick has the same. And again, if you have any issues remembering how to subtract decimals, I show the work over here off to the side. Now we're going to check Sue. So Sue wrote this expression, so we're going to simplify by doing the rule for subtraction and combining like terms, and I see that I don't get the exact same expression. So I'm not going to choose that, say that that was the same. Now Dave, we look at Dave here. Dave, look, I didn't even do any work for Dave because I see these are x's and this is the only constant. So I'm not going to change negative 3.4. And I know from my first problem, I don't have a negative 3.4 is my constant. So I don't even need to do any work for that. I'm not even going to check that one because there's no way it's going to be the same. And for Andrea, same thing. Nope, not necessarily the same thing, is it? Let's see here. Okay, so there's only this x right here, and I see that that is the same as our answer. So I'm going to go ahead and do the work here. But I know that 8.2 take away 3 is not going to give me 60 whatever, right? That's not going to give me in the 60s, so I'm not even going to bother doing that as well. So there was only one that had the same, and that would have been Rick. So we got Rick, Sue, Dave, and Andrea, and only Rick had the same. Okay, so next, number 5. We have this inequality. We're going to solve this by working farthest away from the variable. The inverse operation of negative 10 is to add 10 to both sides. Remember, we only reverse the inequality when we multiply or divide by a negative, so I don't reverse the inequality. I leave them out the same direction. Now I divide both sides by 2 by the coefficient, and this is read x is greater than 7. That means my answers are bigger than 7. So on a number line, here's 7. All the bigger numbers are this way, so that would be an open dot, arrow to the right. The answer is A for that one. So for number 6, it says Lucas is allowed to play video games 60 minutes every Saturday. If he already played 15 minutes, what percentage is left? Well, figure out how much time is left first. So I subtract those two and I see 45 minutes is left. And the question is, 45 is what percent of 60? We can use the percent proportion. Remember, is over of. 45 is what percent of 60? Percent always goes over 100. Since we don't know percent this time, I put the variable there. Cross multiply and divide by the coefficient, and you get your percentage. 75% is left. Number 7 says, Sam poured 2/5 of water in a barrel. There was 10 liters. How much is left? Well, first thing you have to do is not subtract. The first thing you do is find 2/5 of 10%. 2/5 of means 2/5 times. So 2/5 times 10 liters, not 10%, sorry. 2/5 times 10, I would go ahead and do the rule for subtraction, cross out my ones, and I see that there's 4. So in other words, he poured out 4 liters. So how much is left? Now I have to subtract. So remember, first multiply, then subtract for this problem, and you got 6 liters as your answer. So number 8 says an object in a scale drawing is 6.6 inches tall. If the scale is 1 inch to 15 feet, well, that's just 1 to 15, so you just multiply by 15. And there's a review here, how to multiply by decimals, pretend there aren't any, add the decimal in the end. Now, if it said, let's say, 2.5 inches to 15 feet, then we would write a proportion. But since it said 1 to 15, we just multiply by 15. Number 9 says, which vocabulary word means to add all of the numbers in a list and then divide by the quantity of numbers. That means how many numbers there are. And this is also known as average. Well, that is mean. You also need to know the definition of median, mode, and range for the test. So make sure you study those from your notes or your book or the internet. All right, so one circle has a diameter of 40 feet. Another circle has a diameter of 80 feet. So if the diameter is 40 feet, that means the radius is 20. So to find the area of that circle, it's pi r squared. Remember, in your calculator now, you're going to do 20 times 20 first, then times 3.14, and you have the area of that circle. The other circle has a diameter of 80, which means the radius is 40. We have to use radius to find the area. So again, we go radius times radius, then times 3.14. Do not do 3.14 times 40. That would be wrong. And we subtract those two to get our answer. So 11 says, a circle has a circumference of 432 and 200 centimeters. If 2/3 of the circle is shaded, find the area of the shaded region. So we got to find the radius for this circle so we can find the area and then find 2/3 of that area. So that's our order that we're going to do things. So in order to find the radius, we have to use the circumference and the formula for circumference, which is 2 times pi times r, to find r. They gave me circumference, so I put that where the c goes. I always have 2 and I always have pi estimated. If I multiply 2 times 3.14, I get 6.28. It's a good idea just to memorize that. 2 times 3.1 is 6.28. To get the radius, if I have circumference, I simply multiply radius by 6.28. And I'm going to round that to the nearest hundredths. Remember this on the test. Just round to the nearest hundredths there. Okay. Now we're going to use that to get the area of the entire circle. So I go radius times radius. I'm going to round that to the nearest hundredths. It's just going to look more accurate for the answer choices you're going to be given on my test. And then I go ahead and multiply that by 3.14, and that is the area of the whole circle. Now just leave that in your calculator. If we're going to find 2/3 of, remember what we said earlier, 2/3 of means 2/3 times. So I would just simply, in my calculator, I hit this times 2, then divide by 3, and you got your answer, rounded to the nearest whole number. 12, we have a few different shapes. The first shape is a little square on top, a little rectangle on top, not square. And I go 9 times 16, just length times width. I got the area. Then I have a bigger rectangle on the bottom. Take a look at your diagram from your study guide. You see that's a 30 by 12, so I multiply those, I get 360. Now the triangle's a little tricky. You have to get the height, which is actually given to you because it's the same side as this, right? Look at your diagram. Now the bottom, though, to get 11, what we have to do is we're going to have to add 30. I'm sorry, the whole, all the way across is 30, right? This is all 30. But I have to take away that 9 and then that 10. Look at the diagram. Take away the 9, take away the 10, and what's left is 11, and that's the base of the triangle. Remember, triangle is base times height, just like these, but then you have to divide by 2. So you should have got 88 for that one. And then add those 3 up, and you got the area, the composite area of that figure. For 13, they mentioned the word perimeter, so we got to remember perimeter is 2 times length plus 2 times width. It says a rectangular prism is laying on its side. The base is 12 inches tall. The perimeter of that base is 104. So the P is 104. So 2 times the length. They give us length and they don't have width, and that's based on the picture. Look at the picture right now. See why I put the letter there instead of here. Okay? Now, because they're both 2 wouldn't make a difference, but I just want you to get used to plugging numbers in the right spot. So now I'm going to solve this, and when I solve, remember I simplify it first. That means distribute, which I don't have to do, then multiply. Distributing is multiplying, so multiply and then add like terms. There is no like terms to add, so now I just solve by work farthest away from the variable. Subtract 24 from both sides, divide by 2, and I see the width of that rectangle is 40. Then the problem says the length of the whole prism, which is actually used to be the height before it fell over, the length of the prism is 2 times this. So I take that and I multiply it by 2, and I got the length of the whole thing. Now I have the 3 dimensions for the box, and I just multiply those 3, and I get the volume for the rectangular prism. 14 says a large box is 20 by 4 by 4. A small box is 10 by 2 by 2. How many small boxes can fit in the large? Well, if I find the volume for the large and find the volume for the small, just simply by multiplying those 3 and divide those 2, I figure out that 8 boxes will fit in there. So find volume, divide. So next one, 15, says Steve is using a shovel. Now every time he scoops dirt, there's a certain amount of volume, and the volume is equivalent to a rectangular prism that is 4 by 5 by 3.2 inches. So the amount of volume in each scoop is equivalent to just multiplying those 3. 4 times 5 times 3.2, you should get 64 inches cubed. Now he's filling up a hole. The hole is, it's not a rectangular prism shape, but it's the same volume as a rectangular prism that is 20 by 26 by 30. So the whole volume, we just multiply those 3, like we always do for boxes, right? For rectangular prisms. And I get that volume there. Okay, so now I don't just divide these 2 like I did before, because the question says this. Be careful. It says how many scoops, which means divide, right? But then it says would it take to fill in the whole 70% full. So I got to find 70% of this. That's percent proportion, right? But since we have calculators, instead of using percent proportion, we can just do times 0.7. That will give you 70% also. So we're using calculators. Let's go ahead and set the percent proportion aside and just use calculators and do the shortcut there. And now the question is, how many times will this volume go into this volume? So I just divide those 2. Okay, but now we're saying, what's the minimum amount, right? Because we're not going to just round. We've got to make sure we fill the hole. So this is a situation we always have to round up. So this amount of volume has to be greater than or equal to this amount, which is 70% of the whole thing. of the the entire whole. So I divide both sides by 64, because this has to be greater than or equal to that, which means our answer is going to be greater than or equal to 170. Well, the first number greater than or equal to 170 is 171. Take 171 scoops. Now, even if that said 0.3, I would still round up, because even though that would mathematically round down, the hole still wouldn't be filled. So you'd always round up in this situation. That's why I use an inequality. If the inequality part confuse you, just don't even use it. That's fine. Just remember, always round up in that problem. Okay, so we're looking at 16. It says at lunch, you have a t-shirt. All right, so there's 32 small shirts, no medium, no large, no extra large. What's the probability of getting a small shirt? Well, probability means how many out of total. There's 32 larges out of only 32 shirts, so that's a 1% chance, a 1 probability of 1, or 100%. That's what we call certain. So you guys make sure you understand impossible as well. Look in your notes and review that. 17. The table shows the results for a spinner, and they say based on the results, give the number of times an arrow of the spinner should land on purple out of 150 spins. So they're asking about purple. So I look at the table and I see there are 12 purple out of, and then I have to add these up, 12 out of 50. So the question is, how many out of 150? That's a proportion. So if it's 12 out of 50 total, and it'd be how many purple out of 150 total. So I just write a proportion. Make sure I put purple on top, just keep them the same. Then we just cross multiply like we always do and divide, and I see 36 times is the answer. So it looks like we're on 18 here. So problem 18 says a coin is flipped. Well, a number cube is rolled. So what's the probability of landing on heads and then a 4? Well, the probability of heads is 1 out of 2, because there's only one head out of 2 sides. And then it says in rolling a 4. The probability of rolling a 4, well, there's only one 4 on the number cube or die, and there's 6 sides. So if you want the probability of this, and means multiply. So I multiply, and I get about 8%. And the way I did that is I go 1 divided by 12, round to the nearest whole percent. Number 19. So 19 says this. So Jack performed an experiment where he picked brown, blue, purple, and green 100 times. So we've got to pick of this list down here what matches his results. So about 4 times as many brown as purple marbles. That's what happened. That was his observed frequency. 4 times as many brown as purple. So I got to look at my examples and see which one of these has about 4 times as many brown as purple. So let's look at A. There are 15 purple, 11 brown. Well, the browns aren't about 4 times 15, so don't choose A. Look at B. There are 51 brown and 26 purple. Well, 26 times 4 is going to be more than 56, so forget A and B. So now we got a 50-50 chance, don't we? Look at C. 21 brown to 5 purple. Well, 5 times 4 is 20, so that's about 20. So take a look at D. 21 brown, 5 purple. That's about 20 also. So it's either C or D. So take a look at the next one. The next observed frequency was this. He had blue about half the time. So look at C and D. Remember, forget about A and B, right? Those can't work. So C and D, we're going to get blue half the time. Remember, they said we did this 100 times, right? So C says blue is 48. Well, that's about half of 100. D says 38 blue. That's not about half of 100, so the answer has to be C. Problem 20. 50 teachers were asked to share who their favorite teachers were out of Stevie Wonder, George Michael, Adam Levine, and Katy Perry. And then it says pick which statements are true. So statement 1. Statement 1 says that 14% of the teachers prefer Stevie Wonder. So the table, there was 7 teachers out of, and you add those up, you get 50. So is 7 out of 15 14%? When you cross multiply and divide, yes it is. So statement 1 is true. Statement 2 says this. In a group of 200 teachers, it's expected that 56 would prefer Adam Levine. So they said out of 200, so that's a total, and Adam Levine is 56. So we have to use from the table Adam Levine, which is 14, and the total from the table, which is 50. So the question is, does 14 out of 50 from the table equal 56 out of 100 from the problem, statement 2? And if they equal the same, true. Not, they don't. So I can cross multiply that way. They should equal. if these are proportional, or if I see a shortcut, 50 times 4 is 200, so if 14 times 4 is 56, then they're the same. So statement true is 2 also, because they were the same proportion. Statement 3 says, there are 3 times as many teachers who prefer Katy Perry over Stevie Wonder. Well, there are 13 who prefer Katy Perry and 7 who prefer Stevie Wonder. And 7 times 3 is not about 13, so that's not true. Statement 4 says, for every 28 teachers that prefer Adam Levine, 27 prefer Katy Perry. So if I look here, in the problem they talk about Adam Levine is 27, Katy Perry is 28 is Adam Levine, 27 is Katy Perry. So now I look at the table. Table, 14 Adam Levine, 13 Katy Perry. So again, I'm just using a proportion to see if these are equivalent. Is 28 Adam Levines to 27 Katy Perrys the same as 14 Adam Levines to 13 Katy Perrys? In other words, is this proportional? If I cross multiply and they're the same number, then yes. If not, then not. Now let's take the shortcut, okay? If I see 14 times 2 is 28 and 13 times 2 is not 27, then that's not a proportional relationship there. So the answers there were 1 and 2. All right, 7th grade, hope that helped.